I see the flying car industry as game changing when it comes to not only future warfare, but future military operations, just as important, humanitarian relief operations, hurricane support, all the things that we do defense of the homeland. If you start thinking about these devices as nodes in a network, it fundamentally changes the game.
Agility Prime is a program with a vision of world impact. By partnering today with stakeholders across industries and agencies, we can set up the United States for this aerospace phenomenon. Potential outcomes are rewarding and transformative with both military and commercial applications.
I want to offer my congratulations to Dr. Roper and his team for achieving this revolutionary rapid contracting and prototyping method to bring industry and DoD together to develop this new exciting technology with both military and civilian applications. This technology will have great benefit to the needs that we have in Alaska and the Arctic, where conventional aircraft, vehicles, and vessels oftentimes can't operate.
Agility Prime is part of our Defense Department's long history of turning futuristic ideas into reality. I'm proud that the federal government is investing in revolutionary ideas. Agility Prime is leading the way.
This launch of Agility Prime is so exciting. This technology has the potential to make vertical flight more affordable and more widely available. And with the encouragement of the U.S. Air Force and the entire federal government, American companies employing American workers can gain a head start and win a fair share of this lucrative market. eVTOLs have the same agile, vertical takeoff and landing capability as helicopters, but are quieter and should cost much less to operate because of their electric motors.
We are becoming a trusted innovation partner in commercial tech. I could not be prouder of this initiative. I could not be prouder of this team. And I am excited to see how quickly we can go to help commercialize this market for our nation so that our warfighters have options they don't have today, and our nation has an economic advantage far into the future. Innovation is a battlefield, and Agility Prime is just one way we're going to win it.
Agility Prime seeks to ensure a global advantage in advanced logistics technology. Agility Prime can reduce the risk of adversarial commercial dominance resulting in military disadvantage. As the United States Air Force looks at generating combat power away from runways, those distributed logistics aircraft must be runway independent. This new transformative capability is a promising opportunity to conduct that mission in an affordable and a scalable manner.
Today we gather for Agility Prime to drive transportation innovation, lower barriers to entry, and expand our partnerships.
We see a time when automation technologies make the requirements on the pilot much less. And we see flying as being accessible to a much wider range of people.
And it's truly a great credit to Agility Prime. They could put on this virtual event with so many hometowns of the United States represented. You know, industrial base is not really about just what a country can make. More than that, it's about the people who dream up what to make. And then, of course, those people who make it.
Good afternoon, and thanks for joining us for our weekly webinar as we continue our tour through the ecosystem that we have established here with both Agility Prime and NASA. I'm Colonel Nathan Diller here, AFWERX Director and Agility Prime Team Lead. Today, we've got a great lineup, folks. We're going to be talking through a variety of different technologies across AI, autonomy, some computational fluid dynamics services that are out there, a subtractive additive manufacturing, different approaches to data analytics, some UAM ecosystem across Latin America, looking at some of the transportation services, as well as working on eVTOL, or VTOL, and eventually eVTOL. So we've got Transcend Air here talking about that, and then some of the enabler folks that are out there. So appreciate everyone joining. Before we jump right into this discussion, I want to talk just a little bit about some of the opportunities that are coming. As you know, many of our companies here with Agility Prime started their journey with the Air Force through AFWERX, through the SBIR topic. And if you go to the AFWERX homepage, it's afwerx.af.mil. As I think many of you are familiar, we recently added Agility Prime, as well as Spark, as well as Air Force Ventures, all under that same place. And you can see there on the 23rd of October, they'll be opening up the next round of small business innovation research. And these are opportunities that will allow different companies. You can go first look at the eligibility that's there, understand what it looks like, some of the mission areas. You'll see, again, we have published one of the focus areas for Agility Prime that's out there. But understanding the eligibility, looking to see the different approaches that we have from a phase one, eventually to, right, phase one is kind of this introduction. It gives you a chance to go meet different government customers with only about $50,000. I will tell you that we have many of our teams in Agility Prime that started a year or so ago with that $50,000 and now are getting very significant contracts that are out there. That second round, that phase two, is somewhere in the range of $1 million-ish. And then you'll see some of the discussion in there of what we've done with the extended phase two, the phase 2B, or eventually the Strat 5 program. This is the one that allows up to $15 million of SBIR funding for a contract. That $15 million of SBIR funding has to be matched, and it could be different increments, smaller increments, has to be matched by another government equal, so up to at least $30 million. Those contracts could be larger. But then as a way of reducing some of the risk to the taxpayer dollars, we're very intent on identifying those technologies out there that have commercial interest. And so looking for that matching funding from industry as well. So again, if you go on the 23rd of September, you can see some of the initial solicitations that are posted out there. You'll see some of the videos and different approaches to being able to help folks through. And look at that. We can post a link certainly to the SBIR opportunity. Like I said, it opens on the 23rd of September. So you can go see, kind of start previewing those things, and then we'll be closing in October. So certainly invite you to do that. We'll post that in chat. You can see it there at www.afwerx.af.mil. And then if you go look under industry and SBIR, but the AFWERX homepage will get you there. We'll also have a link soon on the Agility Prime homepage so that you're aware of those opportunities. We are looking forward to announcing some of the discussions, the awards for the STTR process. So looking forward to that coming out as well in the not so distant future. If you have questions, there will be actually a webinar for the SBIRs as a separate webinar that will be happening. You can see that there as well. So you can go ask specific questions for your particular company. So certainly invite more partners to come in through both the SBIR, the STTR process, and then as well, the folks that are here with us on the screen today are all partners through this participation in the ecosystem. And this is an opportunity for different companies to show their different roles in this future air mobility space by going to, if you go to the Agility Prime homepage and go to ecosystem, you can register there. You can look across the amazing different companies that are there in the space today. So certainly invite all of you to continue to do that. Just as a quick update on our Air Race to certification. If you're maybe new to Agility Prime, you can also find that as well. We've have now over 15 companies who have applied for that Air Race to certification. We have awarded some of the initial contracts for access to different test resources. And so we'll be able, looking forward, hopefully, in the not so distant future, to show that work that is happening among the testing that's out there. So really across the spectrum of technical readiness levels, across the spectrum of investment, while we're still short of those production contracts, we have a mechanism in place through that Air Race to certification that will hopefully in the not so distant future even create those production contracts. Realizing though that we're not doing a down select, we're not picking 100% the winners or losers, or maybe not excluding the losers. Many have applied to the Air Race and for a variety of reasons, maybe not had the maturity yet, but quickly moving towards that maturity. So this is not a apply once and you're done. It's not a, hey, we were late to the race and so we can't get there. We continue to have that open through 2025. So there's plenty of time, but certainly a bit of an urgency from us kind of being able to get some of these test resources out a bit on a first come, first serve basis there. So with that, as a brief introduction, a little bit of background on where we are, I'll hand it over to Sterling as we continue to tour the ecosystem today. And thanks so much for the fantastic partners that have joined us here this afternoon. Sterling, over to you.
Yeah, for sure. Thanks, Cordova, for kicking us off there. And thanks to all our speakers for joining us and the audience for tuning in again. So we're going to get started today with Stefan Mills, the Managing Director of Spleen Lab, a company joining us from Germany working in AI and robotics. So Stefan, over to you.
Yeah, thanks for the introduction. So I hope you can see my screen.
Yeah, we got you loud and clear, sir.
Perfect. So my name is Stefan. I'm founder of Spleen Lab, and we are doing safe machine learning solutions for safety critical applications, especially automated driving, air taxis, and drones. And today I try to make the webinar kind of a small lesson, not too much a company introduction. So let's start with a simple question. So what is AI for aircrafts and UAVs, or why do we need it, and what properties does AI have? So there are three important things we have to keep in mind. So AI can solve complex tasks in a human-like precision. So it's real-time capable because the design is highly parallelizable, and all over that's what we have to take in mind, is that the algorithms are data-driven. So it's not programmed in a traditional way, it's more trained. And so how could this look like? So let's have a look at this small video, how a drone in real time reacts on its environment, fully automated. It's done in a composement of AI and traditional deterministic algorithms, and it directly looks for a pass that is not hitting an obstacle in real time. It's flying very fast, so it's creating a map, and it's self-localizing without the use of a GPS. And this is how an AI function could look like on a drone, and it's very impressive, and yeah, it's very accurate. And you see at the end, I guess, a real nice 3D map. And this is just a specific function for starting into that game. So what is autonomy? So we have several levels in our automation, and we climb that higher and higher, and the tasks are getting complexer and complexer. So we need AI. But the main question at the moment is, so how can we design a system composed by functions solved with AI that it's also safe? And not safe from a functional point of view or objective point of view, really from a point of view that covers reference standards, for example, the 0178 or something, right? And therefore we need some key asset, and I'm really confident that Spleen brings that asset. So we need a deep machine learning and autonomy know-how, and the more important is also to have a confident knowledge of sensors and the physics of sensors, and have a safety strategy, and the safety strategy regarding the reference standards, right? That's important. Overall, we designed an architecture to solve the full autonomy approach, but also we can pick up single modules and bring it to the ecosystem. So at the moment, we believe in a modularized system composed by different sensors, which is really important, a sensor fusion, perception, a SLAM, and also the model prediction, path planning, and so on. We saw at the moment that perception, for example, like detect and avoid or SLAM as a GNS denied localization is very interesting for the ecosystem. So why is that safe? So on one hand, the modularization keeps us encapsulated from the single modules, right? And on the other hand, the redundancy makes it more stable. And the modularization allows us really to test modules in an encapsulated way. And this is really required by big reference standards and also the redundancy. And this is really important to fulfill the higher automation levels. And we can ask ourselves what is at the moment really redundancy. And for example, I told it, or I mentioned it before. It's, for example, if we use a GPS for localization, right? It's good to have a redundant path that does localization. And here we show a LiDAR-based, centimeter-precise, real-time onboard system that really precise calculates the path of the vehicle itself, right? You see it here. The green path is the localization. It's fully GPS free. It's only by its perception and mapping, the SLAM approach, and we use inside that module also some machine learning components. But this is what redundancy means. So if you have a GPS and there's a GPS denied zone, then it's always good to have a redundancy, and that's important for all the function in the full autonomy system architecture. And yeah, and if it comes to deep learning, it's all around us and it's very famous and everyone wants to do AI. So we have to ask ourselves the questions, what deep learning AI, what is that, right? And at the end, and that's really important for safety, it's a statistical procedure to solve functions. And this statistical procedure means that we don't have a determinism inside. And then when it comes to reference standards, they require from us to provide really a determinism, right? And this is really, really hard then to solve. Like in aviation, we have the DO-178. I already talked about this. And this is very hard, right? Because if you really want to validate a system only composed by a machine learning module or a deep learning module, then you really have to validate the full system all over data. And for example, the standard requires from us 10⁹ flight hours for a high assurance level. And this is, in my mind, it's 11K years. So it's very much, so you cannot validate it. So there are other procedures you need to, you cannot put a full autonomy function only on ML at the moment. It's not possible to validate because of the much need of data. You need a kind of safety by design paradigm. And this is sensor analysis, it's sensor redundancy. It's very important to have a separation of processing chains, right? I want to explain it later, but here, first of all, why is sensor redundancy important? So we saw lots of companies out there only working with camera in the air, only with radar, but it's really important to have a high component of different sensors. You see it here, the sensor fusion has the highest performance symbol in that star plot. And there are a camera which has the capability of a high classification rate because of the big information density. But the LiDAR has the advantage that it can really detect depths to a centimeter precision. And on the other hand, the radar can directly measure velocities of your environment. And if you fuse that at all, you have a very good environmental model and might even not need everywhere some machine learning. And here we provide a technique called functional decomposition, how you can bring AI into that kind of functions. So let's imagine here is some diagram of some flights of us, some modules, and you see a raw camera data and also raw LiDAR data. And we provide here a function, let's call it environmental perception. But we see here some semantics. And we see also LiDAR-based reconstruction. The semantics are out of an AI module, and the reconstruction is fully deterministic. And we see here the reconstruction checks up the model of the semantics, and then we can bring the higher assurance level at the lower processing chain. And this is a kind of a design tool we use for bringing AI really into the architecture to make it safety from a reference standard point of view. And yeah, we developed a sensor cube composed of several sensors. It's low weight, it's with an AI computer inside. You can plug and play to different devices. That's how it looks. And this is how it may performs. So we have here some environmental perception using camera vision. It's fully 360-degree with dual fisheye cameras. We have the LiDAR. Here it's a low resolution LiDAR. We go now to higher resolutions. We have the semantics. And we also have then the full sensor fusion. And yeah, and the environmental model is then the result of it with really semantics in a real-time map, which is provided during the automated flight. Yeah. And yeah, some remarks. We also made the third rank of the most important AI conference in Europe at the Game of Thrones competition with software in the loop, automated flying out of 120 competitors. So this is all to my webinar. So thanks a lot for watching. I hope I made it in time. So I guess I really
Yeah, Stefan, that was great. It's super interesting stuff that you guys are doing out there, and really great visualization to think about how the computers are visualizing the landscape there. So really appreciate you coming on. And I think there's a few questions in Q&A if you want to address those, but I think we're going to switch over now to some more AI work from Sanjay Siv from Near Earth Autonomy. Stefan, if you could stop sharing just so we could switch over.
I stopped it. No, not perfect.
Yeah, so Sanjay, if you want to share your screen there, we'll switch over to you.
Thank you. Let's see here. Okay, can you see my screen?
Yeah, if you could just go full screen, Sanjay.
I am full screen right now. Let's see. Oh, share. Let's see if we stop the share, and I'll share it again. Here, okay. Is this full screen now?
Yeah, we got you, Sanjay. Perfect.
Okay, great. Thank you so much. My name is Sanjeev Singh. I'm the CEO of Near Earth, and I'm going to be talking to you briefly about our company. By the way, great work, Stefan. Thank you for showing our video, the first video of the aircraft flying through the trees. I wasn't going to speak about that, so thank you for showing that video. I'm going to be talking about the next scale up, about the kinds of aircraft that might be used for urban air mobility and military applications. So I'll focus on that today. So put very simply, Near Earth develops technology that enables autonomous aircraft of various scales to be able to do some very fundamental things. And we like to put it in very common, very simple words. We say this technology enables aircraft to fly safe, land safe, do without GPS, and even when things go wrong. Now, these are very simple kinds of phrases, but there's a lot going on in each of them. Flying safe has to do with making sure that aircraft are vigilant of obstacles in the environment, other aircraft that might be flying in the same space, stay clear of them, even when they haven't been coordinated to be so close to the vehicle, to be able to land either in a nominal landing or in a emergency kind of case where the aircraft has to choose between landing spots and to be able to land safely. GPS is a big deal. Many aircraft today are flying without GPS. They require GPS to fly, and it's absolutely essential to be able to fly without GPS. And of course, then we have to deal with all the contingencies to do with component failure or any kind of sensor failure that might happen while the aircraft is flying. So some progression about where we've been. We, for a number of years, we're working on sort of the art of the possible. Is it possible to even fly these aircraft autonomously? The way we fly or so the way we drive ground vehicles, cars and tractors and all kinds of things in the ground, they drive by themselves. Could we do that with aircraft also? So starting in the early 2000s, we got going with some military programs, ending with the 2017 demonstration of a Huey at Quantico. And then more recently, we've sort of transitioned, take all of those good ideas, and what we're doing right now is we're enabling practical applications, not just sort of can we do them. And what that's about is sort of learning what's hard and what's easier, and some economy of scale in trying to bring common components, even though these things might be flying on very different kinds of aircraft. So currently what we're doing is we're scaling to meet the needs of both the military and the commercial ecosystems. I'll try to give you an example of some of these. So our current work is to work with Command Aerospace to bring autonomy to their helicopter, which is called the K-MAX. This is a very interesting helicopter, has a long history of being used in commercial applications, is able to lift about 5,000 to 6,000 pounds at a time, developed to initially help in forestry applications, use a sling load to pull out very heavy objects, also used in construction of highways and other places where large members need to be installed in rugged terrain. And so what we're doing is we're trying to see if we can use these for this aircraft in an autonomous fashion in a military ConOps for logistics especially. The Marines are very interested in using aircraft to be able to do transportation, and what we're looking is all the lessons we've learned boiled down into a small package that can give this kind of an aircraft situational awareness and then allow it to operate in an area where all sorts of things might happen that are not planned for. So we have been thinking about what we call the military ecosystem, which has to do with all of what needs to happen to fly these aircraft safely, starting with when we're just getting going, even before the aircraft is up in the air, all the mission planning that needs to happen, with information from any threat or any no-fly zones that might exist, any terrain that might be present in the area, and then the situational awareness needed to avoid static objects and flying objects, being able to deal with contingencies as they come up, being able to evaluate terrain if the vehicle is coming down in an emergency, to be able to land precisely with very lightweight infrastructure, and then even to be able to land on ships. I know there's a very strong case for aircraft to be able to fly from ship to shore and then shore to ship, ship to ship. These are very important kinds of cases. So we're building these kinds of products or these kinds of capabilities that are modular and can be put into various kinds of aircraft. We have also a very similar kind of a need to do this on the commercial side, and you can see that some of the details are different. In the commercial side, there's a sort of a more typical case is to land in a site that's been prepared for the aircraft to take off and land at. But these aircraft have to be able to evaluate a landing site in case it's coming down in an emergency. You know, we can't imagine that these aircraft will be perfect, or they'll always be able to get to a prepared landing site. So if it has to come down, the idea would be that there would be a map ahead of time as to all the places that the vehicle could come down, and then as it's coming down in real time, it would have to evaluate these landing sites to be able to make sure it's landing safely. And of course, just as well as in the military case, the commercial case also needs immunity to GPS dropout or jamming or any of these other kinds of things. These are very different kinds of ConOps, but what we'd like to suggest is that there are some common needs that can be exploited across both military and commercial use cases. So I'm going to stop here. That's my contact, sanjeev@nearearth.aero, and if we have a couple of minutes before we have time for others, happy to talk about this and any others, especially if there's some questions about the smaller scale, like you saw our aircraft flying between the trees that Stefan showed.
Yeah, for sure, Sandra. Thanks for the presentation. They're a great overview. And then, like you said, just leaning back on a previous presentation on AA, can you speak a little bit on the difference in systems between something for a full-scale helicopter like the Cayman and something like a small drone? I know the weight fraction that the systems take up is much different, so maybe there's more opportunity for a larger airframe, but also more complication.
Yes, when you're flying on a full-scale aircraft like a full-scale helicopter, you're looking at the top speeds, and the flight profiles are quite different than what you would fly at a smaller scale. So at a smaller scale, high speed might be 10 meters per second. Now that's very fast. That drone that Stefan showed that was flying through the forest is flying at 20 knots. And that's really fast when you're flying a few inches away. And so all of what you need to do is to make sure that the vehicle stays safe. Now, at a full scale, if you're flying at 90 knots or 100 knots, which is kind of a typical speed for a helicopter, you have to be able to look out further, and the approach angles are going to be very, very different. The takeoff kinds of procedure, when you're dealing with something like a full-scale helicopter, the flight dynamics are very, very different. Multi-rotor system has the ability to come down steeper glide slopes, but for a typical helicopter, we'll want to take shallower glide slopes, and that changes the perception system. Of course, larger systems be able to carry a larger payload with longer range LiDAR.
Yeah, sure. That's great, Sanjay. So appreciate you guys coming on. Great to always hear from the AI folks. Such an interesting topic. Really appreciate both of you coming on. Now we're going to take a little bit of a transition to Robert Ramsey from Total Sim, who is working in a computational fluid dynamics space doing simulations. So Robin, over to you.
Oh, okay.
Yeah, we got you loud and clear.
Perfect. Okay, thank you. Good afternoon, everybody. And it is a bit of a change from the AI that we've been listening to, but thanks to the Agility Prime team for inviting us to speak today. Total Sim is a consulting company specializing in computational fluid dynamics, or CFD. We have two offices, one in Dublin, Ohio, and we're just a short drive away from the Dayton, where Agility Prime is now headquartered. And we have a second office in California, in Southern California. I wanted to introduce you to a few of our key staff. Ray Lito and Nathan Eagles founded Total Sim in 2009. Ray has a background in racing with over 25 years of race engineering, aerodynamics, simulation, and management experience in Indy and Champ Car. And Nathan has both aerospace and racing CFD experience, and notably spent 10 years with the Williams F1 team starting their CFD department. Andy Liu joined Total Sim in 2013, bringing a background of CFD in the aerospace market. My background is mostly in experimental testing, and I have taken on the role of liaison for the Agility Prime space, which is why I'm presenting today. Total Sim does have its roots in racing, which has pushed us to develop methods to automate processes that return simulation results faster and more accurately. In addition to working in motorsports and other industries, we have been involved in the aerospace market for many years. A few of the aerospace projects we can share are the M10 aircraft up here in the middle, Design's Ascent aircraft, which is on the top right. And we're in the Ascent aircraft, we collaborated with a large development team and did the aerodynamics testing. We also participated as an in-kind sponsor to the Go Fly contest, where we provided our TS Aero app to the participants for the competition. To conduct simulation on a vehicle, these steps all need to be taken. The tools can vary from company to company, and this shows the tools that we routinely use or have used in the past. The simulation process always goes through these steps. Usually when people think of CFD, they focus on the solve part. However, there are many steps to get to the results you need. You need to prepare your geometry, create a volume mass, then you get to solve, and then you need to post-process all the results so that you can actually review them and make changes depending on those results. And in some cases, you'll go into shape optimization. Quality mesh prep is always important for obtaining quality CFD results. So these tools, ANSA, Star CCM Plus meshing, and Pointwise are the meshing tools that we tend to use in aerospace applications. And what we like about them is that they can be interactive if needed, but they can also be scripted to allow for automation of more standard cases. Some factors we think about when we are meshing are things like appropriate spacing near the wall, because it's needed if you want to resolve features like location of the boundary layer transition to laminar to turbulent or anything like that. You'll also want a high overall cell quality, and we'll probably need some refinement in areas where there'll be flow features that affect the overall lift and drag or performance of your aircraft or vehicle. Our meshes are most often a hybrid mesh. It's of structured and unstructured cells. And then we also do a modular volume meshing. And this method allows us to swap out parts without having to regenerate the entire volume mesh. It's a time savings for us. And so, for example, if you have a flap or some other device that you want to try different versions of, then we would section off that part of the volume mesh so that we can just exchange that area of the mesh with the new part. The solvers that we currently most use are OpenFoam, and we like OpenFoam because it's open source, and we can pass any savings on to our customers because it's open source. But often we're using Star CCM Plus for aerospace projects, as it has some additional features over OpenFoam, and it's well known and trusted in the aerospace market. Sometimes we use Fundy 3D, which is also well known as the NASA code. And in all of these codes, correlation is super important to us. So we often participate in correlation studies like the NASA-sponsored high lift prediction, drag prediction workshops, just to keep us connected to the state of the art. Recently, we've been working with a client in eVTOL and have been refining our propeller simulation methods. And what we found as a sponsor of GoFly is that often the external aerodynamics are the main focus by the teams, and whereas the propeller is often taken off the shelf without a lot of analysis. And for a first order design, this will work for you. But as development continues on your vehicle, you'll probably want to do a higher order analysis where you can evaluate the propellers specifically and make sure they're delivering the thrust that you want. As I've mentioned, automation is super important to us, and it's something that we do a lot of. We are always looking for ways to automate a process to improve our accuracy and save time. We do it for simulation setup as well as simulation post-processing. And automating allows you to spend less time manually creating plots and images of your results and more time analyzing your results, which in the end leads to better design. So our background in automating processes led us to develop some web-based industry-focused applications to allow users to do their own CFD analysis. And this is how we became an in-kind sponsor for the Go Fly competition. We provided our TS Aero app, shown at the top right here, to all participants, allowing them to conduct their own CFD analysis. So the TS Aero app allows you to do 2D airfoil analysis, free flight, and also the VTOL settings. We also make it available to a couple of different universities. They use them for their design classes so that they don't have to focus so much on how to create a CFD program, but to use the tools to do some design work. So in the Go Fly competition, we were super happy. Team Tetra was one of the winners in the February 2020 fly-off, and they used our TS Aero app. All these apps are developed for non-expert users and give advanced simulation results and are priced on a run-by-run basis. So it allows you to obtain quality CFD results without having to create an entire CFD department and incur the costs associated with that. So TotalSim has the ability to help no matter if you're just starting on the journey or if you're well into your development phase. The TS Aero app would allow for quick analysis of a single design, or if you're looking for a more detailed analysis, TotalSim's experience in consulting services might be an option for you. And my contact information is down on the bottom right. You can contact me through Ramsey at totalsim.us, or you can contact us through the TotalSim website at totalsim.com. Thank you.
Yeah, no, that was great, Robin. I really appreciate it. I think there's a lot of folks in our ecosystem who would probably looking to get into more complicated CFD, and they could really use some help on that. So appreciate that for sure.
Yeah.
I guess one question for me is for, a small company looking to do a pretty small set of runs on a small geometry like an eVTOL, what kind of pricing, just rough order of magnitude, does that cost? I know that's a complicated question, but just
yeah, it is.
Maybe never asked for a consultant for CFD.
Yeah, I off the top of my head, I'm not 100% sure. I would recommend just people contacting us. Like, the way if you want to use the app, it's really great because you can it's a price point sort of situation. You buy tokens and you can use them to go ahead and run some of your own simulations, and that would be a really good way, I think, for people just wanting to just see what their design looks like to start with.
Okay, yeah, for sure. Appreciate that input. So, and is that app available on the App Store, or how does that work?
No, it comes through, you have to go through us on our website. It's hosted by the Ohio Supercomputer Center, and so you go in through their portal to get to that app.
Yeah, very cool. So if people interested can access the app at totalsim.us?
Yeah, they can contact us through there, and we'll make sure that they get access to the app if they're interested, for sure.
Okay, yeah, perfect. Appreciate that, Robin, and thanks for coming on.
Yeah,
appreciate you coming
happy
on.
to. Thank you.
Yeah, so transitioning over now to some additive manufacturing work from Andy Tran, who's the founder and CEO of Millibot. Andy, I think you're just on mute there as well.
Hey everyone, can you hear me now?
Yeah, we got you, and we can see your slides as well.
Excellent. All right. Well, again, thank you for having me today. My name is Andy Tran. I'm the founder and CEO of Millibot. It's definitely a pleasure and honor to speak with you today about my company, what we do, some of the advantages of our machine platform, and what we're doing to help companies design, prototype, and produce next generation VTOL, eVTOL, and orb aircrafts. So I wanted to start off with a quote. This is from Elon Musk in his Q2 earnings report 2020. And he says, quote, "There's far more opportunity for innovation in manufacturing than the product itself, in order of magnitude." So today I wanted to share with you how this is possible and why we believe the same thing. So what does Millibot do? We build a patented containerized manufacturing platform. It's modular, it's scalable, and our goal is to help you make your dreams come true, providing an enabling technology platform so that you can prototype and test your ideas at commercial scale at an affordable cost while maintaining control over your intellectual property. So basically, rather than outsourcing your production, keep it in-house, vertically integrate. And our vision is to empower the innovators everywhere, give them increased choice for personal mobility solution, allowing designers, manufacturers alike access to these new advanced manufacturing technologies, previously only available through large corporations with big budgets. So our team is a small team. We are made up of innovators and inventors, and we've identified a need for this market. Personal mobility is very exciting to me. So anything basically that people can fit inside and move around, whether that's a car, aircraft, marine, personal mobility. We know it's a huge industry, and we want to help you bring your idea to market. So we're here for you, companies that are bringing these ideas to life. So this is our Millibot system. is a turnkey system. This is not a render. Everything inside the machine is off the shelf, which means everything is modular. You can swap tools, upgrade your machine. Basically, as the technology becomes better, as the hardwares become better, as our OEM suppliers become better, we can upgrade the machines and give our customers enhanced capabilities so that they can start producing, with the latest technology, right? The greatest efficiencies. We have an onboard computer, which could be mounted to the system itself, or it can be controlled remotely through a hub or some sort of interface. This is also the largest build volume per cost on the market. So we've done our comparisons, and I'll go over an example with you later in the slides, how our machines are about 1/8 of the closest competition. And of course, it is a mobile platform, which is very unique. And that means you can deploy your manufacturing anywhere. So if you have, let's say, your facilities are maybe in an area of, wildfires, like right now in California, well, it's possible to relocate your facility to the next location or a different location that's safer so you can continue production, or maybe take it off site, or some stealth environment. So it's a very discrete platform. And again, we take advantage of the different hardware suppliers, Yaskawa, Siemens, McMotion, Hitachi, Highwind, the list goes on. And we're actively adding new suppliers to our chain. And this gives our customers redundancy of parts, and of course, achieve the best cost effectiveness. So I'm sure you've seen this before, the shipping container, they're everywhere. If you have an independent testing facility or production facility, you can easily move your machines there. We have many configurations available, including 3D printers, 3-axis CNC routers, 5-axis routers, laser, plasma, water jets, 3D scanners, and more. So we're just going over a singular system now, but of course, as a company or organization scales using this platform, you can see the cost advantages because in one space, this is a 20-foot containers that you're looking at, 160 square feet of ground space, but if you can stack 6 units on top of each other, that's a 6x production, capacity in 1x production space. So, in the grand scheme of things, if you're lacking in space, then a system like this will make a lot of sense. So again, if you're designing for the factory, or if you can improve the factory, then and you design around that, and that's where I believe, you can gain the most efficiencies, right? So this all started with a vision. 2011, I got into 3D printing. I thought it was the greatest thing ever, but I did realize that there were some challenges with size, speed, and materials. In 2015, I had an epiphany, and that was combining the shipping container with 3D printing to create a large format system that I could produce and create these ideas that, I'm sure one day I'd have, right? So that was the vision there. And in 2019, we're starting to realize this vision. This is actually a production machine that we shipped to a customer, and they're currently using it to produce eVTOL aircraft. It's a 5-axis CNC machine, and it sits in their parking lot. They reached out to us because they lacked the facility space, and they did not want to relocate, and they didn't have the ventilation set up to handle the carbon fiber dust particles. So we built a solution. It's delivered in about 3 months. So this is a commercial ready solution. And they're able to trim the carbon fiber skins for their aircraft. In addition to that, they're able to trim wings on the machine as well too. So this machine serves multiple purposes. This is a different machine. This one's in an aircraft hangar. And here we didn't make the helicopter itself. This is, I believe, is a rotaway helicopter, experimental aircraft. And here we used the 3D printing capabilities to redesign this air duct, which the owner tried to fabricate by himself. using traditional methods, using cardboard to make, the shape and sand and reshape and sand and Bondo. So what we did was we redesigned it, measured it, and on the right, top right, you'll see the integrated part on the that air duct. So he's extremely happy with that, and it's still a work in progress, so the helicopter is not finished yet. But it just gives you an idea of one of the applications of this technology. And that's a small part. We obviously, we can produce much larger parts. On this 20-foot machine, you're looking at a build volume on this particular one of 10 feet by 5.5 feet by 5 feet. And on a 40-foot system, then you could see that going up about 2.5 times. So this is an image of the 5-axis CNC machine. This is on the right side, you'll see the composite skin that is being trimmed. It's about 16 feet long, 5.5 feet wide, and about 2 feet in total height. Now, traditionally, they were using hand tools to trim this part. I believe it was 2 employees and about an 8-hour shift to trim one skin. But we've been able to reduce that down to about 8 minutes automatically, using our system. And again, in the same machine, we're able to trim 2 wing structures, 2 full wing structures, measuring over 14.5 feet long, 2.5 feet simultaneously. So being able to drill holes, create the cutouts for the wiring and for the motors. So this ultimately, again, just helps the company reduce time and cost of producing aircraft, which means they're able to test and validate and get to market faster. On the control side of things, we use a variety of different motion controllers, PC-based or not. It really depends on your flavor. And this means that there's a shorter learning curve. Whenever you're applying, Millibot systems, we can use a controller that you're comfortable with, whether that's a Siemens controller or an open source mock motion industrial controller. It really just depends on what you're looking for, and we can customize the Millibot, for your needs. So, and we're always adding new OEMs to enhance our product line and give our customers more access and more options. And this is an image of our 40-foot system on the left here. This one is it's what we call our 300 series, the heavy duty. It has a glass window in front, so you can still see what's happening on the insides. And on the right side, this is actually a machine we have now. And so you can see the components. It uses really heavy duty linear guides and ball bearing ball screws. Some of the wear and tear parts, they'll last 10,000 kilometers, like for example, a bearing block, and it's under $100 to replace. So very low maintenance on the machine, very heavy duty. And on the next slide, this is our competitive product, or a competitor's product. It's well over $1 million, plus it requires a stationary facility. Whereas a Millibot with a comparable build volume, we're looking at under $500,000. But really, we start our 3D printers at around 150 to 180,000. No assembly required, indoor, outdoor production, low cost, which means higher ROI and shorter time. And, we like to say agility, not facility. So this is the comparison between the different variants of our machine. Each one is customizable depending on what your needs are. And a 20-foot system will produce parts for, up to the size of a small car or a sports car. Of course, 40-foot systems may be ideal for wings or something that's very long, or maybe molds or whatnot. And in terms of materials, I'm sure you guys have questions about this on the 3D printing side of things. We are open source when it comes to materials. So we use off-the-shelf extruder systems. For example, like the ones used at Oak Ridge National Lab that printed the Shelby Cobra, we can actually use that tool head. We've already spoken to the manufacturers. It is compatible with our systems. So any other OEMs that, again, are emerging or out there on the market, we can usually integrate that into the Millibot platform to give you what you want. So if you have any questions, regarding any of our products, we don't build the aircrafts, but we help you build the machines that help you build the aircrafts. And we'd like to, chat with you more if you have any questions. If you're looking for a product brochure or would like to test drive one of our machines, we do have a 3D printer available. It has hybrid capabilities, which means 3D printing and CNC. Please contact us. My information's there, and thanks for having me today.
Yeah, for sure, Andy. Really interesting stuff you got going on there. And just in the interest of time, I'm going to go ahead and usher us along. But thank you for joining us, and I really appreciate it. So next up, we have Evangelos, the CEO and president of United Aircraft Technologies, here to speak with us on data analytics and rapid capabilities for air mobility.
Thank you. You almost got the name right. It's a very difficult name. If Andy could stop sharing, that would be wonderful. The screen. Thank you. So yeah, my name is complicated. My mother and father loved mixing up their names to create my name, but regardless, is everything, can they see my full screen?
Yeah, we got you, ma'am.
All right. So my name is Airbus. I am the CEO of United Aircraft Technologies, UAT, where we are creating technology that essentially will help you no longer have to worry about the integrity and performance of your electrical systems. So let me take you a little bit about what's the current status right now. Right now, as you can see, this is what mechanics have to see. They don't know what's behind the panels. And once they take off the panels, they have all this complexity. Actually, the red bands are metal clamps used today, different connectors and wiring. Of course, eVTOLs don't have this level of complexity, but they still have wiring and high voltage wire. And the way they do maintenance here is mostly visual inspection and locationing and actual physical inspection because there's so much. But this leads to human error because some things are not visual to the naked eye, and we're humans, we make mistakes. So what if we gave them the tools to be able to avoid this? Now with UAT, this is an actual data set sample that we have from a temperature problem. With UAT, the mechanic now, instead of having to take all those panels and all that extra work, can use our platforms and augmented reality to be able to go inside and be able to monitor. In this case, the mechanic can see that it's a temperature problem, and there's not only telling you, hey, this is what's the problem. It's telling you where in the whole system it is and which wire it is, helping improve the process. Now the mechanic can make a very informed decision, go where it needs to go, fix it, and do the necessary steps to be able to avoid the problem. And with all this data that they have, it will be able to tell you, you have X amount of time left before it becomes a real issue. So it provides an opportunity to do condition-based maintenance. So how are we doing this? We're doing this by replacing the metal clamp that most aerospace use today with a lightweight thermoplastic clamp that is faster, lighter, cheaper, smart, because it has a network of sensors embedded in. As the first presenter said, that's made a good point for it. It has a complete set of sensors that help monitor and remove the redundancy for the electrical systems. And it uses augmented reality and artificial intelligence to be able to do so. And with this, what is helping it you do, our system is not only, you can search by date, you can also search by timestamp, helping you make informed decisions and avoid maintenance that if you have to do it, take from days down to hours or from hours down to minutes, because currently there's nothing out there that easily in situ will be able to tell you where a fault is located. And with us, as we explore the eVTOL market and as we continue to grow and all these amazing manufacturers create their models, and as they begin to age, we're going to learn a lot more about that wiring system, and having access to this data and the tools to analyze this data, they'll be able to reiterate and improve upon their designs. And that's where we come in. And not only, of course, by monitoring as well. So a use case scenario is, here we install our clamp, we connect it to our software, and then we set out their threshold. So meaning if you flip a switch off or you flip it on, it will not pick up any discrepancies. It will have a threshold. And then after that, it is connected unique identifier on a one-way ask-receive basis. And what happens is you turn it on. When we turn it on, it's working. Everything's fine. Visually we see nothing's happening, but our clamp picked up a problem. And the problem picked up, there's a loss of amperage, but the system is on. So the system is on because amperage is still flowing enough to be able to turn it on, but it's not at full capacity. And because we can't see, what happens is with the constant vibration of this aircraft, their wire shaved. And if we do not pick it up early enough, this chafing will eventually lead to loss of power or any other complications. But our clamp can help you avoid those. And this is based on personal experience. Darian, the guy right in the middle, he was an aircraft electrician for the US Army and has over 12 years of experience in this field. He worked with the systems, understands the problem of troubleshooting them until he got injured because of the metal clamps today. This led for him to lose his job, his home, everything. Then he created the ICC and created a solution. Together with Donnie, we came together with him and created UAT. Donnie is a US Army captain retired with over 20 years of experience in technology development, and I myself have experience with business to government and business to business development for over 10 years. And so what does this mean for the eVTOL? Here you have this, we all seen for Agility Prime, this beautiful aircraft, and it's built wonderfully. But once you put the panels in, some areas can be hard to access, and to take them off is very time consuming. So as the aircraft continues flying, it continues aging, sometimes this maintenance is gonna be more difficult. But having eyes on board, you will be able to tell, hey, this seems to not be performing as it's supposed to. I know exactly where to go instead of having to take everything off. And to give a little company overview, we have a manufacturing facility. We're ISO 9000 compliant. We worked with a DoD before, so a very good experienced teams that have done projects for the Department of Defense, and we have capabilities of producing over 1 million units per month. And on the development side, our team is aerospace focused, led by Gerardo. He was a prior senior engineer for electronic development and manufacturing for IBM, with over 20 years of experience, all the way to an AR lead that worked for NASA in development projects. So our current status for the base, our base model has passed the testing based on mil spec, mil standards. So it's ready to go. And on our sensing clamp, we have developed all the sensors, and currently we are putting them in a smaller printed circuit board. So we essentially can automate our manufacturing process, be able to produce more efficiently, and start being able to use more for larger scale testing and implementation. So why we're here? We're here because we believe in what Agility Prime is doing and what all the manufacturers are doing. We believe urban mobility is the next step for human and urban transportation. So we want to work with the manufacturers, help them through the design stage. Because of our open and integratable system, you can either use our UI UX, or we can just give you the backend support. And because of our modular system, we can adapt to what each specific manufacturer needs. So we would like to continue working with them and with the Air Force and Agility Prime as we have in the past, and continue moving forward. So I appreciate everybody here doing these presentations, and for Agility Prime giving us the opportunity to speak to you guys, and I'll take questions.
Yeah, that was very interesting. A couple questions I have. How do your sensors communicate? Is it over RF or Bluetooth, or are they wired?
It's over Bluetooth. Each sensor has a unique identifier. It communicates over Bluetooth on a one-way channel.
Very interesting. And then I guess the other question I have is, do you rely on the airframe manufacturers to develop the kind of augmented reality model, or you guys do that in-house?
We do that in-house. Our team is equipped with the tools to be able to go in and be able to produce that AR model ourselves.
Very interesting. And then I guess the other question I have is, how do you rely on the initial design to choose where the sensors and clamps would be, or is that kind of an integrated process with your team?
That is an integrated process with the manufacturer. As they develop and they adapt to their electrical system, we will adapt with them. So when they put the initial design, we'll be able to put our clamps in, see how everything's working. If they change it's something that's easily changeable. We don't need to adjust anything or update anything. It's something that can be swapped in and out.
Yeah, and then I guess I assume it's pretty simple to add your system as a modification to older aircraft, but do you see a huge advantage of doing it from a clean sheet design from the start with your system in mind, or?
Sure. Our clamps were originally designed for rotorcraft. Was designed for that aircraft frame in mind, but because of our design, it's easily applicable for the electrical industry. So working with us early on is help us be able to create adaptations specifically for that manufacturer. So we already worked with a couple other electrical manufacturers. So we already are getting their feet wet in and understanding the process. So helping us through it will make it far much easier and customizable.
Yeah, no, that's very interesting. I know the Air Force is definitely exploring the idea of augmented reality for maintenance. So definitely cool to see you guys working in a similar field.
Interesting. Thank you.
Yeah, thanks for coming on this week. And switching over now to Mr. Felipe Veron, the founder and CEO of Veron Vehicles Corporation. So Felipe, over to you.
Yeah, thank you very much. Is audio good?
Yeah, we got you loud and clear, sir.
All right, good. So I'm going to use our website here to describe who we are. I want to first thank the U.S. Air Force and Agility Prime and all the group for inviting us to be part of your ecosystem. It's been great subsystems and technologies that we've heard so far, and I want to thank all of you guys as well. We are in a bit of a different scenario in urban air mobility. We are leading an ecosystem ourselves. So as such, I think it's going to be a bit of a turn in subject here. And I want to start by saying that we are a U.S. company. We're called Veron Vehicles, and I am the founder and CEO of the company. And we chose to implement what we're doing in Latin America because we saw that it was, and we learned that it was faster and essentially there were less costs involved in a simpler approach towards urban air mobility. And we're really ahead in doing just that here. We are a disruptive infrastructure company. We are not developing any of those technologies ourselves. What we are doing is bringing all those parts and bits and pieces of UAM and integrating everything to build what we call the infrastructure networks. And what we call infrastructure networks, I want to show you this video here, is a collection of vertiports connected to each other via airspace volumes linking those vertiports and air vehicles servicing between them. We are not developing the air vehicles. We're not developing the systems for airspace integration, but we are indeed working with all these ecosystem participants that we have in our ecosystem to develop those parts and to work towards an implementation of a first infrastructure network. We're starting in Latin America. And we're working very closely with the Colombian government and the Colombian civil aviation authorities in developing everything that has to do with being able to ultimately provide a service to customers. Our first customers are going to probably be logistics companies. We don't see passenger transportation as a first step in urban air mobility. That's actually what we call our run phase. Before we run, we know we have to walk. And even before we walk, which is freight transportation, we first have to have other approaches to even earlier implementations of urban air mobility. And that's a roadmap. And in this entire endeavor, we are indeed calling in for participants to our ecosystem, UAM stakeholders from the world, and we have a lot of participants already. So if you are a company who is developing subsystems for urban air mobility, or if you are an air vehicle OEM or designer, or any other type of urban air mobility stakeholder, we invite you to come and learn more about us, get in touch with us. We have a place where we can, and we are implementing urban air mobility. We also have other ecosystems as part of our ecosystems. We have, and we're sharing with ecosystems in the United States, in Canada, in European countries, in Asia, and also in Africa, where we're sharing about the question, all right, how do we implement urban air mobility? How does this whole thing really get its feet on the real world and get started? And there's a whole bunch of questions there and barriers and challenges that we are, of course, trying to overcome as we move forward towards implementation. There's two ways in which you as an urban air mobility stakeholder can get in touch and working with us. One of those ways, and I want to move down in our website here, is if you are looking for an ecosystem where to implement your systems first, you may want to get in touch with us, because this is a place where we are bringing all those different light bulbs, which we're not developing ourselves, but we are indeed producing an entirely new lamp with all those different light bulbs that companies like yourselves are producing. And that new lamp is what we call urban air mobility in Latin America. Turns out that the mobility problem in the developed world and in general, urban air mobility in the developed world is something that differs quite a bit from what urban air mobility has to be in the developing world, where the nature of urban structures are different, where the mobility problem indeed is very, very different, and where there are different cultural aspects to public adoption and public acceptance as well. So we are working and developing that. So if you're looking for an ecosystem where you would like to have your systems first deployed and tested, flown, and everything that entails all the way to placement into operation, please get in touch with us, and we'd love to share more with you about what it is exactly that we are doing. You can see a brief overview of our urban air mobility concept and how we are setting out to have a simplistic approach to make urban air mobility happen faster and at lower costs in this part of the world. Here in this section of our website here, I want to mention the other way in which you can get involved with us, and it's Skyscraper. I want to use this very valuable opportunity to tell all the Agility Prime community about Skyscraper. Skyscraper is our virtual summit. It's happening in November 18, 19, and 20. And in Skyscraper, we're going to be disclosing and sharing a whole bunch of conclusions of the currently ongoing work about the requirements of urban air mobility in Latin America. As part of the Skyscraper efforts, we have our think tanks, and our think tanks are happening now. Actually, we just had our number 3 think tank this morning, and it was about vertiports, and we're having very, very interesting and knowledgeable panelists from our ecosystem involved in these think tanks to share not only their views, of course, around the different subjects, but also bits and pieces about what we are doing in our private collaboration with all the different partners that we have. Here you can see an overview of those different partners and participants that we have in our think tanks. And you can also see and register the different think tanks down here. So just as a brief introduction to Skyscraper and our think tanks, which is another fantastic way in which you can join Varón Vehicles and what we're doing in Latin America. So I just wanted to use this opportunity for this very short introduction to Varón Vehicles. I do have a question here from Alex. He's asking which of the countries in Latin America have also manifested interest. Actually, we're having quite a bit of participation from different countries, governments, and private companies from different countries in Latin America. Our outreach goes to the region around Colombia. We're very involved in Colombia with the Colombian government, with the Colombian civil aviation authorities. We're doing everything that has to do with implementation work, airspace volumes and airspace integration architecture development together with the Colombian civil aviation authorities for this that you're seeing right here. And we're doing work in the different aspects and the spokes that have to do with urban air mobility, from vertiport design to all the way to insurance work, for example. And we're seeing a lot of activity in other countries like Panama, Ecuador, countries in the Caribbean. We have collaboration with Brazil, with Mexico as well, and several others. So our outreach is really regional in Latin America. I thank you all for the opportunity in Agility Prime for us to allow us to convey what we're doing through this channel. And I'm open to contacts and questions from anybody who's interested in further talking. Thank you all very much.
Yeah, thanks for coming on, Felipe. Really enjoyed it, and great work you guys are doing down there in Colombia. So appreciate you coming on, and hopefully you guys get some new contacts. So switching over now to Mr. Peter Schmidt, the co-founder and COO of Transcend Air. Peter, off to you.
Hey, thanks, Sterling. Let me share my screen here. So in the ecosystem today, I represent aircraft manufacturers. Actually, in our case, really, we don't want to be the manufacturer. We're designing the VI 400. And the title of my talk today is VTOL Now, E when ready. And not when the aircraft is ready, but when batteries or other electric sources are ready for the aircraft. So my contact info is here on the cover page, peter@transcend.aero, if anybody wants to reach out via email and follow up. And I'm going to run through this pretty quickly. So I would be glad to talk in depth after the presentation if anybody has questions. So with that, what makes for a successful aircraft program? This is the question that my co-founder, Greg Bruhl, our CEO, and I asked ourselves before I quit my day job and went full-time on Transcend. And the answer we came up with is demand. Lots and lots of demand. That is proven, not imagined. So our focus is on developing an aircraft that can meet proven demand. Because sadly, most aircraft that can be built technically won't be built. Because beyond demand to bring an aircraft to market, you need a design that can meet it while being certifiable without excessive cost, certifiable without excessive risk, certifiable in a time frame that enables a competitive return on investment, manufacturable at a more than competitive profit, or why would anybody want to build your aircraft instead of other things, operable at a more than competitive profit or cost to private owners, and upgradable as needed for the foreseeable future, which for an aircraft is 20 to 40 years. It's hard. Worse yet, most aircraft that are certified profit someone else, if at all. And that's because if you're applying new technology to a new aircraft, that takes time and effort to get right. And that extra time and effort adds cost, it adds risk, and it impacts the ROI timelines. And so all of that is a negative. And it's one of the reasons why it's so hard to bring new aircraft to market. So the next question we asked ourselves is, what if you don't want to go bankrupt and let someone else make all the money off your aircraft? So the answer we came up with is target already proven markets with a low risk, high technology readiness level design. So that's our approach at Transcend. So we've designed an aircraft that will fill two proven market needs. That's for VIP helicopters and regional airline service. It's manufacturable and certifiable today under current rules. It will be profitable for the manufacturer, which won't be us. We're going to run the airline. It's going to be profitable for the operator. That will be us. Should be liked and trusted by passengers, of course. And it has to enable lower prices for aircraft and fares. And what Greg and I bring to this is an outsider's perspective, if you will. Greg really sort of brings the passenger's perspective, and I bring the Part 135 air carrier perspective. And I'll tell you, like my quote here says, until I got into trying to make money with aircraft at this scale, I had a lot of false notions about how people think about and buy air travel. And I systematically disproved those notions over 5 years of attempts at linear air. And we've brought that directly into the design of our business model as well as the aircraft. So as part of that, there's a wait for some new technology in this industry, and that's batteries. And what I've got here is a projection of pack level battery energy density in watt hours per kilogram based on historic growth rates. This is based on Don Hillebrand and others' works at Argonne National Laboratory. And if you look at historic battery capacity growth, it's been between 3 and 5% for the past 100 years. There was a period where NICAD grew at 8% a year. So I've plotted those three curves on here. I reckon today we're at about 200 watt hours per kilogram on a pack level, certifiable pack level basis. Pack level means with all the cooling, all of the shielding, all of the controls and everything necessary for safe operation in a certified aircraft. So if we progress at 8% per year, then we'll achieve 1,000 watt hours per kilogram, which is what our aircraft needs, in approximately 2041. So that's an issue. Now, if it takes longer than that, of course, it's much longer. So the opportunity cost of waiting that long is really high. So our approach is, the Vi-400, our aircraft, make money now and electrify the aircraft later. So we've cleverly designed the aircraft that we can replace the jet engine and the fuel tank with electric motors and batteries in the same locations and actually electrify fielded aircraft using a supplementary type certificate in the day when batteries get good enough. And if that happens faster than these graphs suggest, hey, that's great, we'll electrify sooner. So again, that's perhaps a little bit of a controversial take in this world of eVTOLs, but as it said, we're a VTOL now and E later. So why do we think our program is going to succeed? Well, again, we're going after three markets. Two of them are already proven. People buy helicopters today, and they buy about $4.5 billion a year in helicopters that are used for VIP transport. In addition, when we look at targeting regional airline service with our aircraft, we can offer cheaper door-to-door service than current Uber plus airline plus Uber costs by using VTOL. And that's going to generate an additional potential $9.6 billion a year in aircraft sales. And then there are military applications, which we've only started to even think about, primarily because of AFWERX. Fortunately for us, the VIP market alone has the lots and lots of demand we need for our program. And why would people buy our aircraft instead of a helicopter? Well, it's 24 times better. It's half the price, it goes 3 times as fast, and it has 1/4 of the operating costs per mile of a medium twin helicopter like an S-76 or a Leonardo AW139. So we really think of this as the world's fastest and most price or cost-effective helicopter. It's faster than turboprops, and it sort of looks like a turboprop in airplane mode, but it doesn't have the range. So it doesn't really compete effectively with fixed-wing turboprops because it just doesn't go far enough. But it does have the range of a helicopter. We're glad to report that we were the Robb Report winner of Best of the Best in Aviation for 2020 for VTOL concept. And along with that, for helicopter, the Airbus Ach-131, the Aston Martin edition. And I like to point out that the Ach-130 is also a single engine turbine rotorcraft. And look at the difference in legroom between the two. That's one of the other benefits that comes with having a wing on our aircraft, along with the high speed and the fuel efficiency. A lot of people look at our aircraft and go, oh, tilt rotors. It's another tilt rotor like the V-22. That's really expensive and complicated. And it's like, well, it's not a tilt rotor, it's a tilt wing. And we don't use rotor heads. So we use variable pitch propellers with collective in helicopter parlance, but no cyclic. So we just say, our motto is just say no to rotor heads. If you look at how complicated that rotor head is in the lower right-hand corner, they're amazing mechanical engineering marvels. And I'm just, I'm in awe of the engineering prowess that Bell and others have developed these things. And we're not doing that. We're going much simpler with the same kind of propellers that, a King Air has. And what the result of that simplicity is much lower cost. So these aircraft are shown to scale. So you can see the Vi is much smaller than a V-22. And it's coming in at $3.5 million in airliner trim versus $71 million for the V-22, $24 million for the civil derivative, the AW609. And the fundamental reason for that is just less complexity. It takes cost out throughout the entire lifespan of the program. We're not just about pretty renders. The lineage of our aircraft includes 16 flying prototypes that have informed the design since 2009. We've tried flying a lot of different VTOL configurations, and most of them don't work very well. So we're happy that we have that experience to get us to our tilt wing configuration that we are flying. One of the aircraft we built was a 2,000-pound manned aircraft, and that was a really good lesson in flight test and safety and building larger vehicles. That one wasn't electric. It had a supercharged Hayabusa motorcycle engine. We're currently flying a couple 1/5 scale prototypes to further validate our design and act as flight dynamics and flight control system laboratories. So they support our other analysis methods and simulation methods. So what I'll tell you is that we think of the Vi-400 as having proven technology that gets put together in a new way to create a disruptive aircraft. And some of the other specs are, it's very fast. You know, this is not an orb floating from building to building. This is a bullet going 352 knots, which is over 400 miles an hour, from city to city regionally. It'll climb at 4,700 feet per minute plus in helicopter mode. That's 3 times faster than fully loaded twin helicopters can go. It'll climb at over 8,000 feet per minute in airplane mode. It's fuel efficient. It uses half the fuel per mile or kilometer of an OH-58D, the Kiowa Warrior. It's very simple. This is part of the lack of complexity. We don't have any hydraulics. It is all fly-by-wire. I talked about it being tilt wing, not tilt rotor, and it has one single turbine engine, which we can do because it also has a whole airframe parachute. Affordable, 3.5 million airliner trim. Effective. Sanjeev mentioned the autonomous command KMAX helicopter that they're working on. That's had great success in the with the Marines. If you run the numbers, an autonomous Vi can deliver about 33% more cargo per hour than a KMAX can. So that's speed versus slung payload. And as I mentioned, it's future-proof. It's turbine mechanical to start, but the fleet is field convertible to electric. So, you know, the summary here is VTOL now, E when batteries are ready, and we look forward to that great and glorious day. And I look forward to seeing it in Air Force low-vis gray at some point too. So with that, I'll pause in the presentation, just see if there are any questions.
Yeah, for sure, Peter. I know we're coming to the end of the webinar here, so I'm going to move us along quickly, but thanks for coming on. Always great to hear from you, and best of luck with your continued progress there.
Oh, my pleasure, Sterling. Thank you.
Yeah, so switching over to our last but not least speaker here, Sergio Sekura, partner at Sng Consulting. Sergio, over to you.
Thank you, Sterling. Thank you, Carl and Diller as well for inviting us. And I am going to share my screen. I hope you guys can see it. Our company, Sng Consulting, is a consulting firm that its goal is to help companies in the Agility Prime ecosystem enter successfully the market. We work in 3 different industries, markets: aerospace, defense, and automotive. In aerospace, basically, we work throughout the entire space. We started working in automotive as well for the similarities that autonomous vehicle and electrification has with the aerospace world. We work with OEMs, we work with tier 1 supplier and aftermarket suppliers. We were funded in 2012. We have locations in Arizona and in California, as well as a team of international seasoned experts, both in commercial and product area. Moreover, we have an extended worldwide network of engineering experts that can help with your need in airworthiness, avionics, flight control, and flight test. The area of expertise that we can help with. One of the main points of Agility Prime is to help with a product that needs to be commercialized, so to make it successful in the commercial market. For this, we can help with a lot of the different pieces, from business case development to understanding your customers, to comparing your product to your competitors, to launching the product, to communicate about the product, all the way to actually finding the money to get this product to the finish line and find investors as well. So what about advanced air mobility? So we got interested in the advanced air mobility market, and we have been an active participant since 2017. We think ourselves as thought leaders, we make it our business to know everything that happens in the industry. And we publish many reports, including what I call mini reports that are freely available on our LinkedIn page. We have an extensive network that includes all of the major OEMs, tier 1 and aftermarket suppliers. We already helped several clients enter this market. And right now, what we are working on is expanding our presence in other regions like Europe and Australia. Now, one of the things that we were asked not just to talk about our company, but to a little bit share our work. And so it's what I call story time. One of the things that we looked at, and we are part of the Varon Vehicles ecosystem, is to look at, is there a case for a regional advanced air mobility vehicle? So the hypothesis is that the vehicle that we're designing for the typical US city, in this case, for example, you can see the Uber sizing for the mission, might not be suited to topographies in the rest of the world, especially in emerging markets that have very poor mobility solutions, and so could actually benefit from a vehicle like this. Felipe talked about Bogota, and as you can see, it is a city that would greatly benefit from a new way of transportation. So let's talk a little bit about this. So if you look at the city of Bogota, this is the geography, and you look at this 25 miles radius, you will see that we're basically designing a regional advanced air mobility, urban air mobility solution, not an urban one. Now, instead, if we were to restrict the range to 6 miles, so design a different vehicle, now you can see how it fits the urban environment. When we think about the US, if you were to design a vehicle with a 6 mile range in Los Angeles, you would have a vehicle that basically doesn't even serve 1/10 of the LA County, or maybe 1/20th of the LA County. If you look at 25 miles, now you begin to have a vehicle that has the range for serving the entire Southern California region. So what is the idea? So the idea here is a regional vehicle specifically designed for emerging markets with a different mission, different range, different speed, different propulsion solution, built to local aviation regulation, and something that follows the example of the automotive industry. I think in advanced air mobility, we need to look at the automotive industry. What you see in the background, for example, is a two-seater vehicle designed, under design by an Indian company, for example. With this, what we want to show is that we spend time thinking about this market, and we bring to you a different way of seeing the market that you commonly see yourself. So how can we help the Agility Prime ecosystem? We can help the Agility Prime ecosystem either understanding the market. We have extended market research and analysis, and we're developing specific tools to parse through the market entry. If you look at the number of players in this market at the OEM level, it is the 1920s of the car industry, the 1930s of the 1940s of the aviation industry. It is difficult to understand who are the winners. And while some of the larger companies, you can understand who the winners will be, there is also a significant amount of other companies that are interested, but we don't know. And so we're developing tools to help you quickly understand what are the entrants that you should be talking to if you are a supplier. And in this case, it's a live tool. It's a tool that continuously updates. And it shows basically the commitment and the reality of these different entrants. As far as the other part is, we can help you enter in the market. We can help you understand your portfolio. If there is gaps, new product to be developed, some product to be changed, understanding what's your business case. How do you commercialize the product so that the help that the Air Force is providing with the Agility Prime is a booster for what are going to be your commercial products. We can help you finding sources of funding as well as understanding your supply chain. And last but not least, when the time comes, help you with communicating specifically to your audience about your product, as well as help you with the launch. Our aerospace clients are far and wide. We work with a lot of different suppliers. We work with a lot of MRO and aftermarket companies, tier 1 companies. This is the one that allowed us to talk about. There is many more, especially companies that we work in the AAM industry that for obvious reason we can talk about. And to close, why would you want to work with us? What makes us different? What makes us different is that while we work on the dark side of the business side of the house, we are engineers. And so we do understand the engineering problem. We work for or with all the companies that you are targeting. When we work with you, we listen to what you want so that we can propose a solution that works for you. And last but not least, we will never ask for something from you unless we deliver something to you. So if you want to contact us, this is my contact information with all of the social media modern stuff that is there for us. And if you have any questions, please do not hesitate to contact me. And once again, thank you guys for having us.
Yeah, Sergio, thanks so much for a great presentation. A few people in chat, I think, that wanted to reach out, but since we are a little bit over time, I just want to say thanks for everyone for joining us, for the speakers and for the audience, and we'll see you again next week, as always. Thank you guys. Have a great weekend.
Thank you all.